Hello folks, we come to the part 6 video of this exercise 10.3 and now we are in the 15th problem. So let's complete the 15th problem and see how it goes. Question says that there is a line L which is having the equation y equal to mx plus c. There is a perpendicular from the origin which meets the line at minus 1, 2. The perpendicular from the origin to the line y equal to mx plus c meets it at the point minus 1, 2. You have to find the values of m and c. That's what the question is. They ask us to find the values of m and c. Now, let's have the introduction as usual. Let line L, comma, points O, comma, A be as shown in the figure. And then we'll get across looking at these. Right, now because this OA is perpendicular to L, automatically we have this slope thing. Right, so let's find therefore slope of OA, which we could call it as M or something, is y2 minus y1 by x2 minus x1. So it's minus 2. Since line L is perpendicular to OA, therefore slope of line L also we can find. Slope of line L is going to be minus 1 by this m. That means minus 1 by minus 2, which is half. Therefore, m equal to half. Now, but minus 1 comma 2 belongs to the line L, so it will satisfy. So therefore, y equal to mx plus c becomes what? It becomes 2 equal to half times minus 1 plus c, because whatever we knew we have substituted. So it's like minus half, and it goes on the other side and it will become plus half. So what will happen? We'll equalize into 2 into 2, 4 plus 1, 5 by 2. So you get m and c. M for us is half and c for us is 5 by 2. That's what they asked us in the question. They asked us to find the m and the c value. They found it. Right. That's our problem number 15. Then we'll quickly move to the problem number 16, which says that if P and Q are the lengths of the perpendicular from the origin to those two given lines, then you have to show this. From the origin, you are having perpendiculars, and its length is P here, its length is Q here. Lines are given to us. They ask us to find out whether this condition holds true or not. Distance of a point from a line, we have learnt ax1 plus by1 plus c by root of a squared plus b squared. Good old days. There's some problem back. Right, so we can use that very easily. We can use it and we can get across doing this. L M O. Let lines L, I don't know where we'll require, but let it be lines L comma M and points A, B, O be as shown in the figure. Right. Now, perpendicular AX1, as I said. Therefore, distance OA. For once, I will just write the equation because it's been like quite some time since we have done this. So, with this, distance OA, which is P, is equal to, you have these substituted here. So those are all zeros, it will go off. And only C, which you have to bring it on this side, minus k cos 2 theta by root of a squared plus b squared, which means cos squared theta plus sin squared theta, which is 1. So that way you will get minus k cos theta 2 theta becoming plus or minus p, but fortunately we are taking p squared, so it doesn't much matter. So let's take the square. P squared will become k squared cos squared 2 theta. Let's have that as equation 1. Means we'll use it elsewhere. So also similarly the distance OB will become by this formula 0 minus k by root of sec squared theta plus cosec squared theta. Right, and this distance is Q for us. So Q equal to minus K. We're making it a little relaxed because we have the because we have okay.